Okay, hello. So you did some things with standard form. Now we're going to do that with intercept form. It's going to be a little bit more complicated, but we'll actually be able to, right now we'll be able to get a lot more out of intercept form, and intercept form will actually seem very useful. Well, it is very useful. But yeah, similar idea to the last lesson, but now we can actually do more with intercept form right now, or we will do more. This is what intercept form looks like. It's all factored. You could have a number in the front, or it could be just like blank and it's an imaginary one. And then you have these two things. It can also be something like, it could be something like y equals, it could also be like this. Because square just means multiply it by itself twice. So this is also just like the same thing as this, but this is written nicer, so we write it like this. So this is another example of something in intercept form. You just need you basically just don't want any addition or subtraction signs outside of the parentheses. And then that's intercept form. Okay, so this is a little quirk that will help us lead us to our first point about intercept form. So when you can convert between standard and intercept, and just like, let's imagine that we have something like this that's in standard form. We're just going to focus on this a here in the front. All the other numbers we don't have to worry about. A is our coefficient of x squared. So when we convert it to intercept, that's when we basically factor. If you remember, when we factor, you first pull out this number in front of x squared, so you get something like this. So these numbers here now will be different, but that's fine. We're still not worrying about them. And then from here, you factor it. So you factor this thing on the inside, and you're going to get something like this. The important thing is that this a is still here. This a did not change. It's still in the front, and it's still there. And if you remember, the a in the last thing you're doing, this coefficient of x squared is very important, and like tells us if it's going, like the parabola is an upwards u or a downwards u. And it's the same thing as this one here. So this is going to be very similar to standard form, where we look at this number in the front, and that decides if it's going like this or it's going like that. If it's positive, then it goes up in both directions. If it's negative, it goes down in both directions. And like, you basically just need to know that these two numbers are the same. So they're going to just do the same thing. So yeah, this is really the exact same idea as before. You just need to know that it's the same. But the other cool thing about intercept form is that these two numbers over here also tell us a lot. So those two numbers will give us our zeros, actually. So let's do this example. Let's look at this thing. This is an intercept form. And we're going to figure out the zeros of it. And a zero, there's two ways to think of it. Zero is like visually, that's like the points on your graph where it hits the x-axis. It's like these two things I'm highlighting. Here are the zeros of this parabola. But you could also get it by just trying to get y to equal 0. That's why it's called a zero. And yeah, these 2 points are 0 on the y-axis. So how do we get y equal to 0? So for this thing here, for this to be 0, well, this is 3. So this is a bunch of multiplication. So we're doing 3 times something, 3 times something, times something. To get something to be 0, this multiplication problem to be a 0, either this thing needs to be 0 or this thing needs to be 0. There's one 0, no matter what the other thing is. Let's say this is 5. If this becomes 0, then the whole thing is becoming 0, because there's multiplying. Whenever you multiply something by 0, it's 0. So basically, we need to either get this to be 0 or this to be 0 for y to be equal to 0. I'll repeat myself because I don't like how I phrase that. To get y to be equal to 0, this needs to be 0 or this needs to be 0. Okay, let's go more in depth. How do we make x minus 2 to be 0? If you make x 2, then it will work. So this, if it becomes 2 minus 2, then this would be equal to 0. For this other thing, x plus 3, you need x to be minus 3. So 2 and negative 2, or 2 and negative 3, these are our special numbers that are our zeros, because they get our y to be equal to 0. But there was even a faster way to do it. You can just look at this equation. Well, like here, So the zeros are 2 and negative 3. But the faster way to do it is just look at the equation and switch the signs of these two numbers. So negative 2, you can switch it into 2. And 3, you can switch it into negative 3. And that's kind of the trick here. I want you guys to know a little bit of why it works, but this is the trick. You can basically, you get your zeros by looking at these two numbers and swapping their signs. Yeah, the zeros are, well, it's also important to know, when you have an equation like this, it has two zeros. And the two zeros are these two numbers, but with their signs swapped. And yeah, you can plug those numbers back into the equation. See, yeah, that works. And like another little interesting case when you have something like this, which is technically also an intercept form, it's going to have 1 0. And it's only going to have 1 0, and it's going to be this number, but with its sign swapped. The graph's going to look something like this. This is what a graph looks like when it only has 1 0. Something like that. So yeah, 2 zeros. This is what the equation looks like, and you get it by swapping these two numbers. When it has 1 0, it looks like this. So again, you get the 0 by swapping the sign of this number. If there's no zeros, it's an interesting case. So let's recall things. So there's this one assignment, can you factor all quadratics? It kind of just like showed you some quadratics that were like very clearly impossible to solve. And yeah, you can't factor all quadratics. It's not possible. So our two facts, so like from this thing, we know that you can't factor all quadratics. We also know that you can get to intercept form by factoring. That's how you get to intercept form. So connecting to these two ideas, you can't always get a quadratic into intercept form because you need to factor it to get into intercept form, but you can't always factor it. So sometimes you have equations that just can't get into intercept form. And those are the ones that have no zeros. They look something like this. They don't ever hit the x-axis. The equation of this graph here, you can't turn it into intercept form. Okay, I think I'm going to do, a little review now. Okay, so this is intercept form. This a in the front, if it's positive, the graph will go up on both sides. If it's negative, it'll go down on both sides. Or if you want, you can think if it's positive, it's a U. If it's negative, it's an upside down U. To get our zeros, you look at these two numbers and swap their signs. Flip the signs. If it looks something like this, though, it has 1 0, and that 0 is, once again, this number, but with its sign flipped. And if there's an equation that is not factorable, okay, it can't go into intercept form, it has 0 zeros. Okay, that was probably a lot. Let's look at this through Desmos. Let's first look at this first point. So I'm just gonna make something in intercept form. I'm so zoomed in. this is something in intercept form. Right now, this coefficient in the front is positive. If you make it negative, it's again, it goes down, no matter what. It's still going down. I can mess with the other things, but it's still going down. Still going down. Be a small negative still going down. Small positive going up. Big positive still going up. Yeah, so positive going up, negative going down. Next points. So this thing here. Oh, wait. Okay, yeah. So let's look at this. For this equation, so it's going to say that our zeros are these two numbers, but with their signs flipped. So this number over here is 3, so one of our zeros should be -3. And then the other one of the zeros is this one flipped, which is 4. Let's go look at the graph. Is that correct? Yeah, -3 is one of our zeros. 4 is our other zero. What if does it still work if they're both negative? Now, they're both going to be positive now because they're both switched. 3 and 4. 3 and 4. What if they're both positive? Opposite of 3 is -3. Opposite 4 is -4. -4, -3. Yeah, you can try it out yourself. This always works. Let's look at something like this. So this is the one that's supposed to have only 1 0. So let's say if we make this now squared. Yeah, 1 0. It should be this thing with its sign swap, so -3. Oh, it's not showing it to me because it's bastard. Yeah, but -3. If it's like something like that. Once again, it should be this sign swapped. So now it's 3. 3. Lovely. Here, I'm gonna just make an equation that can't be factored. Here, let's do it like that. So this is an equation. So I started with something like this, and I was like, okay, to make it not factorable, I'll put it up more. And yeah, so this doesn't hit the x-axis, so it has no zeros and shouldn't be factorable. Let's ask Google. Can you factor? Okay. When you see the eyes, this is imaginary numbers. So basically, we might go into imaginary numbers, but maybe not. But either way, this is, can you factor with real numbers? Hello AI? No, it cannot. Yeah. Let's do another example. Maybe if I make, let's do like -10 -10. That too, that's very similar. Here, I'll put a -2x. Can you factor real numbers? No, cannot be factored. Lovely. So yeah, hopefully that matches up with all this. It has no zeros. It can't be factored.